Okay, welcome back, everybody. We have another topic of areas of other shapes that we have not done yet so far. Today, we're going to take a look at the area of a circle and area formula for regular polygons. First of all, let's talk about what a circle is. So, a circle is a set of all points in a plane that are a fixed distance from a point called the center. So, you see in my diagram here that point A is the center of that circle. Why is that not moving? There we go. Okay, sorry. Anyway, point A is the center of our circle. And we got some vocabulary associated with a circle that we want to talk about. Radius is going to be a line segment connecting the center with a point on the circle. So AF is a radius, AB is a radius, AE is a radius. A diameter of the circle is a segment which has 2 points on the circle, but which also passes through the center. So segment FE is a diameter. We also need the circumference of a circle, which is like the perimeter. It's a distance around the circle. Okay, so that's the circumference. So we're going to have two formulas which relate to a circle. The first one is the circumference. Before we get to that, though, let's think about this number pi, the most famous number in the world. Pi is 3.14159 and goes on forever, never repeats, never stops. But pi comes out of the circle, and so pi is the circumference of the circle, so the distance around the circle divided by the diameter. So that's true no matter how large your circle is. The pi is always going to be the circumference divided by the diameter. So if you take that formula right there, pi equals circumference divided by diameter, and multiply both sides by d, we get that equation solved for c. So c, the circumference of the circle, is the pi times the diameter of the circle. There's another form of that, though, because we know that the diameter is 2 times the radius. Diameter of a circle is 2 times the radius. We can replace diameter with 2 times r in the formula, and we'll get circumference equals 2 pi times radius. Just by replacing this d with 2r gives you circumference equals 2 pi r. So it's another version of circumference. We're not going to prove the area formula for a circle. We're just going to give you that. So the area of a circle is pi r squared. So now you have that. And to summarize everything we want to know about the circle in the red box here, the circumference is a pi times the diameter, or 2 pi times the radius. And the area of that circle is also pi r squared there. Okay? Let's do a problem with the circle here. So it says find the area and circumference of circle P in terms of pi. So all we need is our formula. So c equals pi times diameter. We see the diameter of the circle P is 16 centimeters. So circumference equals pi times the diameter, which is 16. But we're going to write that pi at the end. So we're going to say circumference equals 16 pi. And it's a distance, so we're going to have to put some centimeters on there for our label. For the area of that circle, the formula calls for area equals pi r squared, so we need to know the radius of the circle. So the radius is half the diameter, so the radius is 8 centimeters, so we're going to have pi times 8 squared. But we're going to write that as 64 pi, putting that pi at the end. And don't forget, we need units, so that's 64 pi square centimeters, so we need the units on the end as well. Okay, now let's talk about something a little bit more complicated here. Area of a regular polygon. We had the word regular when we talked about triangles earlier. We had a regular triangle we said was a triangle which has all the angles congruent and all the sides congruent. Well, the same word regular goes for all polygons. So a regular polygon is a polygon which has all the sides congruent and all the angles congruent. So we can talk about some terminology related to regular polygons. First of all, a regular polygon has a center, just like a circle does. Center is equidistant from the vertices. So these points are obviously the vertices. So if you connect that center with each vertex, that's going to be the same distance. So those are also called radii of the polygon. So that's what the center is. Central angle, we also have this terminology for a circle, but we're going to deal with it today with the central angle of a regular polygon. You see the red angle there, that's a central angle. So that's a angle which has a vertex on the center of the circle. So this central angle has a vertex right there on the center of the circle. Here's a new word for us, apothem. So the apothem of a regular polygon connects the center and is the distance from the center to the side of the polygon. So that apothem right there is green, and so it connects, it goes from the center and is perpendicular to the side of that polygon. That's called the apothem. It's the distance from the center to the side. Okay, now here goes something a little bit more complicated. So this is a regular polygon, and now if we take that, that's an isosceles triangle there because it has two congruent sides, or the radii of the polygon. So if we pull that out and look at it closer, you'll see something like this. So that's an isosceles triangle again. This base of the isosceles triangle is a side of that polygon, so we're calling that S for side. This A is the apothem of the polygon, so we're going to call that A. So let's say that this isosceles triangle came out of a polygon which had n sides of a regular polygon. The area of one of these triangles, remember there's going to be n of these triangles inside that regular polygon if there are n sides. There's going to be one triangle for each of the sides. So the area of one of those isosceles triangles is 1/2 times base times height. Well, its base is S, its height is A, so the area of one of these triangles is 1/2 times S times A. But now imagine, remember, we got n of those isosceles triangles. So the area of n isosceles triangles is n times the area of one of them. Remember, the area of one of them was 1/2 times S times A. Now, if we got n of those, we have n times 1/2 times S times A. Now, if we just rearrange those four numbers a little bit, we'll have this expression here, 1/2 times A times N times S. I just rearrange these four numbers, put the 1/2 out front and switched around some of these numbers inside. Now, think about this. The perimeter of the original polygon is N times S because remember the original polygon is N sides and each of them are the same and each of them is S. So N times S, N times the sides, the length of one side, is the perimeter of the polygon that we're trying to find the area of. So the perimeter P was N times S. So if you go back up to this formula right here and replace N times S with P, then that's going to give us an area formula for that regular polygon. So it's actually pretty simple once you have the formula to use it. The area of a polygon, a regular polygon, is 1/2 times its apothem times its perimeter. Okay, and we're going to get a couple examples to show that. Okay, so this example says find the area of the regular hexagon. It's supposed to be regular. It doesn't really look like that, but it is. So the regular hexagon, so the number of sides is 6. Okay, so we have our formula now, which is really helpful to us. The area of a regular polygon is 1/2 times apothem times perimeter. We're going to get it as an exact answer and also as a decimal. So the area is 1/2, that comes from the formula, times the apothem. Well, notice they're giving you that apothem, 3 times the square root of 3, times the perimeter. Well, the perimeter, each side is 6, and remember, that's a regular polygon, so there's 6 of those. So the perimeter here is just going to be 6 times 6. It's 36. So the perimeter of that regular hexagon is 36. Okay, so we're going to put that in for the perimeter. Okay, so if you multiply all that out, you're going to get 54 times the square root of 3. Remember, you're multiplying 1/2 times 3 times 36. That's 54 times the square root of 3. So that's an exact answer. An exact answer contains a radical. So if you want actually an approximate answer, that's when you actually multiply that out, 54 times the square root of 3. So I'm going to take 54 times the square root of 3, and 93.5. 93.5. And so both these, by the way, these are areas, so these are going to be square meters. I should have written that on there. So this is actually an approximate answer. You would think that would be more accurate, but actually it's not. The answer with a radical in it is the exact answer, and that radical 3, when we could do the calculations, rounded off. So it's an approximate answer. Okay, so we got one more of those area formulas for a regular hexagon, and then that'll wrap it up. All right, this is a little bit more complicated. This time we got a regular pentagon, so n is 5, so we have 5 sides. Now let's talk about that central angle right here. This is a central angle. We're going to find out how many degrees that is. If you had all those central angles drawn in there, okay, let's get rid of that. Thank you very much. Try that again. There we go. Get all these central angles drawn in there. I don't know why that keeps coming up, but it does. Okay. They would all be the same because these 5 sides are congruent, and so their central angles would be congruent. So what I'm trying to say is here, if you look at this angle right here, it looks like a circle. That's 360 degrees. You divide that by 5, like in this problem right here, we got 72 degrees. Each one of these central angles here is 72 degrees. Okay, try to erase that. There we go. So if you take this angle right here, that's going to be half of 72 degrees. That's going to be 36 degrees. Because these two triangles here are congruent by HL. So since they're congruent, then they have corresponding parts of congruent triangles are congruent. Okay, now let's pull out that 1/2 times apothem times perimeter, because we're trying to find the area of this pentagon. 1/2 times apothem times perimeter. Okay, so I'm going to write this as decimal. So we got 0.5 times the apothem, which we're going to come back here and get in a minute. We're going to leave a space for that. And then times the perimeter. So perimeter, this side here, recall, is 8 inches because you've got 4 inches for this piece. And remember, these triangles are congruent, so that's also 4 inches. So you've got a total of perimeter for this pentagon to be 5 sides times 8 for each side. That's 40 inches. So that goes into our formula right here for 40 for the perimeter. The last thing we've got to do is we've got to find this apothem right here. Does everybody see the apothem? We can do that because we had that previous chapter on trigonometry. We're going to use the tangent ratio. All right, so the tangent, 36 degrees. I'm looking at this triangle right here on the right. Tangent 36 degrees, according to SOHCAHTOA, is opposite, which is 4, divided by adjacent, which is A. Okay, so if you recall how to solve that for A, you've got A tan 36 is equal to 4, and then solve for A. So A is equal to 4 divided by tan 36 degrees. Okay, so we're going to calculate that, and that's going to go in our formula for area. So I got 4 divided by tan 36. It's going to be 5.5. So that apothem is 5.5 right there. That goes into our area formula right here, 5.5. Now we can calculate the area of that regular polygon. So you got to use that old geometry as well as the new stuff. So you got 0.5 times 5.5 times 40 equals 110. So that is the area of that regular polygon, and that's going to be in square inches because we're dealing in inches here. Okay, there you go. Let's wrap this up. First thing we talked about was area and circumference of a circle. Area is pi r squared. Just memorize the formula. Circumference is pi times diameter, or 2 pi times the radius. That's what you need to know about a circle. What you need to know about a regular polygon mainly is its area formula, which is 1/2 times apothem times perimeter. Okay, so you're going to need some practice on this. Let's go ahead and get some practice with the assignment, and good luck.